right, so this is the last section that's going to be on your quiz. We will go ahead and do section 13.4 before we take the quiz, just because we don't have time to really take a full day off to do review before the quiz, but only sections 1 through 3 will be on the quiz. So equations of tangent and normal lines is what this is about. So a tangent line we've already talked about is a line that touches a curve at a single point on the curve. The slope of that tangent line is at a given x value is found by finding the value of the derivative at that x value. Well, a normal line, and if you look at the picture there, is a line at a point on a curve that is perpendicular to the tangent at that point. So wherever it's tangent, it's perpendicular at that point. The slope of the normal line, because it's a perpendicular line, is found by finding the opposite reciprocal of the value of the derivative of the function at that x value. So if you find what the slope of the tangent line is, you can find the opposite reciprocal, and that's the slope of your normal line. Okay, so find the gradient of the tangent and normal lines of f of x equals 2x squared minus 5x plus 1 at x is equal to 3. Well, before I can find the gradient of the tangent, I need to find the slope. So find the derivative here first. That's going to be this function right here. F prime of x is going to be 4x minus 5. So the gradient of the tangent line at x equals 3, we're going to do f prime of 3. 4 times 3 minus 5 would be 7. The gradient of the normal line, that's going to be the opposite reciprocal slope. So 7, think of that as 7 over 1. That would give me a negative 1/7. Okay, and that's it. All right, so next, find the values of x that would give a horizontal tangent line to f of x is equal to 2x squared minus 5x plus 1. Okay, so remember, the slope of your tangent line is equal, it has to do with the derivative and the value of the derivative. If I have a horizontal tangent line, then that means that my slope is 0, because a horizontal line has a slope of 0. So if my slope is 0, that means that my derivative is equal to 0. I just have to figure out where is it equal to 0. So my derivative is equal to 4x minus 5. I'm going to set that equal to 0. Now, if they had said, what value of x gives a tangent line with a slope of 1/7, let's say, then I would plug the 1/7 in and I would solve. Now, that's a horrible number to solve for, but it's the same idea. I know the slope is 0, set the derivative equal to that slope. So we solve this, we end up with 5/4. You could do that as a decimal. It is a nice decimal, but I would just personally prefer to do it as a fraction. Okay. Next example, state whether the functions below are increasing, which means positive slope, or decreasing, which means a negative slope. So looking at A there, we're looking at x equals 2. So here's x equals 2 on my graph. So as I'm going from left to right, and you always look at functions from left to right, as I pass through 2, the graph is going up, so it would be increasing. So that's all we really have to say there. Okay, now what if they give you an equation, though, okay, and they don't give you a graph? Well, you could graph it, but let's say that maybe you can't for some reason. Well, then we can figure out if the value is positive or negative for that derivative, and that'll tell me the same thing. So f prime of x is equal to negative 4x minus 3. Plug negative 2 in, so negative 4 times, plug positive 2 in, sorry. That's going to give me 8, 9, 10, 11. So since f prime of 2 is negative, the function would be decreasing. Okay, now why is that? Again, the derivative has to do with the slope. So if my derivative is negative, that means it's a negative slope. And negative slope means decreasing. Now we get into actually writing the equations of the lines here. So write an equation for each line, then graph the line in the original function on the same grid. All right, so to write an equation for a line, I need a point and a slope. So looking at A, the tangent line to the curve f of x equals x squared plus 3 at 1, 4. Okay, so there's my point that I'm going to use. I just need the slope. So to find the slope, I'm going to need to find the derivative. So the derivative of f of x would be just 2x. The 3, remember, turns into a 0. Now, I need to know where am I finding the slope, because this is a curve. I could find the slope lots of different places and get different answers. They want me to do the tangent line to the curve is at 1, 4. So I'm going to steal that x value. X is 1, so I'm going to find f prime of 1. And they have to tell you where, okay? So my slope is 2 at an x value of 1. Now I can write my equation. So I'm going to use this point, and I'm going to use this slope. Y minus 4 is equal to 2x minus 1. Okay, keep going here. Y minus 4 is equal to 2x minus 2. Y is equal to 2x plus 2. Because when I add 4 there, that's what I would get. Now, graph the two on the same grid. So there's the original function there. There's my tangent line. You can type this in the calculator and then kind of sketch the equation out here. So y equals, already on y equals there, right? X squared, can't remember the equation, sorry. X squared plus 3. And then 2x plus 2. Oh, hold on, sorry. Well, we'll take this as a learning opportunity here. All right, so if you have a window that's messed up like mine is, go to Zoom. Well, okay, hold on a moment. Oh, never mind, I think we're good. All right, go to Zoom. Here we go. Go to Zoom and go to 6 for standard. That puts your graph back to normal. So there's my original parabola. And there's the tangent line. So you can see there that it does touch in just one spot. Now, as far as graphing this, I need to put it on paper. Now, you can use your table to get some points here. Now, you're going to notice two sets of points. The blue points are for the blue graph, and the red points are for the red graph. Now, the red graph is just a line, so I don't really need that to be able to graph that. But I do need to have with a parabola, you have the vertex, so I do need to make sure that I graph that. And I need it to fit on the grid. So really, these 3 points are the only points that are going to fit. And then I'll graph some of the other points there as well. So let's see. We've got 0, 3, and 1, 4. 0, 3, 1, 4. Okay, so here's my parabola, the original function. And then 2x plus 2. Okay, here is my y-intercept of 2. Up 2 over 1. Up 2 over 1. That didn't really come out so well. Let's see here. Well, it's just because we really need more points than that. And I even missed the point when I'm drawing it on there. But you get the idea. If we plotted all the points there correctly, the point that they would have in common is actually right there at 4. Right. Okay, one more. This time we're doing a normal line. So you're going to start off just like you were doing a tangent line. Now, the one big difference, though, on this one is that they didn't give me a point. They just gave me the x. So I do have to find out the y that goes along with that x. So f of 9 is going to be 2 times the square root of 9, which would be 2 times 3, which is 6. So the point we're using is 9 comma 6. Right? Now, find the derivative. So 2 square root of x is the same thing as 2x to the 1/2 power. That would be the same thing as 1x to the negative 1/2 power. Now we don't normally write an x to the, or we don't normally write a 1 in front of that, but whatever you want to do. Now we can actually leave our answer like that. We'll go ahead and get rid of the 1 in the front there. I'm not really supposed to write negative exponents, but this is not my answer, so I can leave it like that, and I can go ahead and put it in the calculator. So we're going to take 9 to the negative 1/2 power. You can type that in your calculator, again, just like that. Make sure you put the power in a parenthesis, and we'll end up with 1/3. Now, it won't give that actual 1/3 to you, so there's really 2 ways we can handle that here. Go back to the calculator here. If I type that in, so 9 to the negative 1/2 power. Now, if you've got the calculator like me that puts the power up in the air there, I don't really need to have it in parentheses, but if it doesn't do that, then that's what's important. Okay, so it gives me 0.3 repeating. Now, that really is a fraction that you should know off the top of your head, but if you don't, if you hit the math button, number 1 there will change decimals to fractions for you. And there you are. Now, the other option would be, instead of doing it as x to the negative 1/2 power, think of that as being 1 over x to the 1/2. Think of that as being the square root of x, 1 over the square root of x. So if I'm doing 9 to that power, then it ends up being 1 over the square root of 9. 1 over the square root of 9 is 1/3. So you can get there more than one way. But I think they would like you to use 1/3 as opposed to using the 0.3 repeating, especially since that number right there is the tangent slope. I want the slope of the normal line. So if I've got a 1/3, the 1/3 is going to become opposite reciprocal, is going to become -3. So that is my slope. This is my point. Now write the equation. So y minus y is equal to my slope, x minus my x. So y minus 6 is equal to -3x plus 27. Y is equal to -3x. Uh-oh, something's wrong there. Oh, okay. So on my paper, I put 3 times 9 was 18. So that's going to be 27 plus 6, that's going to be 30. Oops. Sorry, it's got a mind of its own right now. There we go, plus 33. Okay, so over here then, that should actually be a 33. I'll have to fix that. Come to the calculator here. So we've got the original function, 2 square root of x. Okay, and then down here we have y equals -3 plus 33. Oops. Okay, graph. I don't know why the small graph there isn't coming out right. But there we go. So I don't know how well you can tell there, but that normal line is making a perpendicular with whatever my tangent line would be there. Sorry, I'm just looking at this again because the number doesn't seem to be as good as when I had it as a 24. Hold on just a second. Okay, everything's right. Now, if you notice, this equation looks a little bit different now than what it did, or the graph looks different than what it did before. This graph isn't square, so like when I when I look at it like this, I'm going from -10 to 10 on both axes, but look at the axis. You can tell that the ticks are farther away on the x-axis than they are on the y-axis. So the graph looks skewed, so things don't look the way that they necessarily should. So the way that you can fix that is if you go to zoom square, number 5, there's more ticks on the x-axis now, but the space between them is the same as the space between the y's. So when it graphs the two equations now, you can look at that and you can see, yeah, that red line looks like it's perpendicular to the blue line, which is what it's supposed to be. Okay. Now, to actually put that on the paper, again, you can look at your table. Now, a square root function just kind of starts in the middle of nowhere because you can't obviously take square roots of any of these numbers. So I'm just doing a sketch here. We'll see. Nope, we're done. Don't keep going. There you go. So I can really only do the points that are from 0 to 4. And then, but as far as with the other line there, those are big numbers. I'm not sure we're actually going to be able to do it on my small grid that we have here, but we'll make it work. So we're going to go 0, 0, 1, 2, and 4, 4. So 0, 0, 1, 2, and 4, 4. So there's my curve there. Now, obviously, I can't really plot a y-intercept of 33. So if we look at some of the numbers that would fit on my grid here, that's going to be from 0 to 6. Go back to my table here. Well, yeah, 0 to 6 is still going to be too small to fit on my grid. So we're just going to kind of eyeball this since we don't have a grid that's big enough. So kind of out here somewhere, we're going to have our line that's going to do that, which would be at a right angle. So sorry about that. I may, by the time that you actually have the notes for this, I might actually have a bigger grid that I could fit on here. So you would just plot your points to graph that line there. We're not going to be able to, again, do a y-intercept of 33, but I can find some points that would fit on the grid here. It's just that none of the points that we have that are going to be, well, none of the points that we have will fit on the grid. So, all right, so sorry about that. Again, that's the end of what you're going to have to do for the quiz. I don't know if you'll have any graphing or not, but you will have an outline given to you that'll say whether you have to do graphing or not. Just haven't totally made the quiz yet when I was doing the video here. So, as always, let me know if you've got questions.